Okay, let's give you guys some more practice. So try to explain to yourself why you can't use a comparison test to decide if this series will converge or if this will diverge. So press pause and have a go. Okay, so if you look at the direct comparison test, it requires you to have non-negative terms. So if you look at this, one over x squared will look something like this. And then if you look at the negative version, it's like this. So if you look at this series, you've got positive, negative, positive, negative, positive, negative, and so on. It requires it to be non-negative. You've got a negative here, you've got a negative, and a negative, and so on. So the direct comparison test won't work for this series. And then if you look at the limit comparison test, well, even with the limit comparison test, it requires an to be above 0. It requires bn to be above 0. So here you've got something that's negative, negative, negative. So the limit comparison test won't work either. Okay, so next question. So hang on. So try to explain to yourself why you can't use the ratio test to decide if this series will converge or if it will diverge. So why can't you use the ratio test on this? So press pause and have a go. Okay, so if you look at the theorem for the ratio test, well, if you look at this, if you look at sine of x, it will look something like this. Hang on, let me draw that again. It will look something like this. But here you require an plus 1 divided by an. So sine of an plus 1. So that's similar to this. Plus 1 and then divided by sine of x. Well, here's your graph of sine of x. This is your sine of x. If you look at this graph, it will move it across by 1. So it would be something like this. It would be something like this. It gets moved across to the left by 1, but then you've got 1 divided by the other. So here, at this point here, you're going to have to divide by 0 here, and then hang on. So this is your sine here. At this point here, this thing here is going to be, you're going to divide by 0 here, and then here you're dividing by 0. So something weird happens at pi, and something weird happens at 2 pi. So you're going to have an asymptote here because you're dividing by 0 here. Well, if you get a graph plotter and plot sine x plus 1 divided by sine of x, you would get something like this. You would get something like this. So here you've got an asymptote here, a vertical asymptote here, and so on. Well, in order for you to use the ratio test, you have to have a limit. You see the limit of this, there is no limit. If you look at the theorem for the ratio test, it requires you to compute the limit of this thing here. Well, if you look at the graph if you look at the graph back down here, there is no limit. The limit does not exist. So in order for you to use the ratio test, the limit of this thing here must exist. In our case, for sine x plus 1 over sine of x, the limit here does not exist. So you can't use a ratio test.